Thank you very much for the presentation. It's great, simple to understand. If you have any questions, any clarifications that you might need, please just you can put on your mic and then you ask. Let us interact a little bit before we close the session for today. There's a question in the chat. Are there libraries of examples of archetypes or of full models? And where can they be found?
Okay, so the two main sources that I used for this presentation are the main one that provide many of these archetypes are Braun. It gives you a list of all the different archetypes. And there's also Wolstenholme. He's in 2003, 2004. I don't have that link on here yet, but these are very nice articles about the different archetypes. I've had seen many different lists of different archetypes between the 10 and or 12 specific ones. There are many sources on the internet that you can get them, and there are also some very good sources. I think there's a guy called Kim that also have very good articles, guidelines on how these archetypes look like and how you can use them.
Yes, I will share some of these resources with you. There are quite a lot of archetypes out there. Like I said, there are 12. There are some cases there are 15. So it depends on it really depends on what you want to model. What your objectives are. Then you could actually go to the Bible or to the library of archetypes, because each of the archetypes actually explain different situations, like the limits to growth say something else, the shifting the burden say something else. And then I've actually used it as well. So there are quite a lot of them. I'll share some of these resources with you so you can see how to explain each of them and how you and when you can use each of them.
I would also
John,
say
you can ask your question.
Yeah.
Yeah.
I would just want to add quickly, if the systems thinking is continuing to grow and use in different disciplines, each discipline, I would say, have their own problems, and that will lead to more and more different archetypes being identified. And also many of the archetypes that I've seen are derivatives of existing ones or of specific applications of these initial 10 or 12 from Sengi and from what's the other one, Meadows. So many of them available as well, and they continue to grow as people use them and found some derivatives and specific instantiations of those archetypes. Yeah, and that also, they call them different ones, but they have the same underlying issues and structures that they address. Yeah, okay, next question.
John, your hand is up. You can ask your question now.
Can you hear me now? Good evening, everyone.
Yes,
please, I want to ask because I did a master's at the University of Cape Town, and I used systems dynamics for my master's studies, and my master's supervisor only focuses on my master's supervisors. They only focus on qualitative system dynamics. Okay, now I'm doing a PhD at the Graduate School of Technology Management at the University of Pretoria, and I'm also using system dynamics to answer some of my research questions. So I wanted to ask, is the qualitative system dynamics or the archetypes enough for a PhD study? Because I've interacted with most people who have, they've also told me that no, this can't be enough for a PhD. You need to go down to quantitative and so on. So that's my question. If yes, how many of it should you use? Because I've published a paper where I only use one archetype, and the paper is out there. So, and somebody has also told me that using just one for your PhD is not enough. So I wanted to find out if they are wrong, or maybe I'm wrong about this idea.
Interesting question. It's difficult to answer that. I would say it depends. It depends on what you want to achieve with your system dynamics modeling or with an archetype. What is the problem you want to solve, and what is the research you want to do? And I think that will play a big role in how much is enough.
Okay. Okay.
Okay, but we must can have a chat offline about this.
Okay, sir. Okay.
And it seems like you guys are actually in the same school, so
Yes,
you guys can chat.
yes.
Yeah.
There are some questions in the chat. Let me just go through them. Abdullah, yes, I will put that video in a Dropbox and then I'll send the recording to all of you. Then the bank is actually under system analysis. In terms of converting the hypothesis to quantitative, is it dependent also on the data collected, or is it just interpreting the simulation result?
Yes, data is important. If you have that, you have data from your system that represent your system, I think it's important to use it to try and get a deep understanding of your system. There are many papers around qualitative and quantitative modeling of system dynamics and the different aspects. In my personal opinion, I think you can use both, and I think if you can use them in combination and supporting each other, I think that can work as well. But if you have the data, why not using it? But it is independent also the data collected or just interpreting. Well, the thing is you must compare your simulation results to something. How do you know your system is giving the right behavior? I think that part is important as well.
Okay, great.
Okay.
There's another question. Did you want to say something else?
No, I'm finished. Okay, are we going to look at Oleg's comment? What kind of analysis would you suggest can be performed on causal loop diagrams? Forrester was saying that we cannot model complex systems in our heads, therefore simulations. I think, yes, your causal loops help you to model it, but the causal loops are not really suited to do your simulation of really predicting what will happen if things change or so. So for that, you still need to convert that to your simulation models. Okay, causal loops help you to understand your system and doing your systems thinking about the system behavior. But if you really want to try and learn about it and see what the effect of different changes to the system is going to be, then you really need to look at doing a proper model of the system. Does that answer your question, Oleg?
Yes, this is perfect. Yeah.
Okay, thank you. Mark, can you please show again the example of the fourth archetype and explain it a bit? Okay, let's go through the others first. Yes, you will get the slides, John.
Okay, thank you.
And how can a monitor or can a monitor or supervisor help me conducting a project? I don't know what the context of the question is, Faranak. You need to interact with the stakeholders, depending if you need someone to help you. Okay. I think we all here are willing to do that. I don't, Jong, what would you suggest?
Maybe he should. I suggest that he should join the society, and then perhaps we can actually have some of this conversation offline to know exactly what kind of help he will need and how we can assist.
Yeah, there are many people within the organization that is willing to help and to get people started within the environment. But I think it just join first. I think the first point of access will be through the website. Okay, Sunita, please, how much quantitative data can be considered sufficient to do a simulation for the system? Well, I would say, first of all, you need to also provide mentorship for free. Yes, gift. This is also that it is available. Sunita, it depends. Again, it depends on how deep you want to go into the simulation, how big is the problem, how big is the simulation. It's very difficult to answer a question like that. It's just like asking how long is a piece of rope. We really need to understand exactly what you mean. Obviously, more is better, I would say, personally. But it depends. You must have the right information and the right data, and I think you must understand your data. And I think that's actually more important. Corneille, I think you try to come in here from the side. Maybe you can have an answer for us.
Oh, thank you, Rudolph, for the presentation. I don't know if I have a proper answer for that question. I think the way you explained this is exactly right. So actually, I had a different question, but my 2 cents on what you're saying is that it really depends on what you're trying to do. Some things in the system you cannot even measure them, so you can't obviously get data for them. But some other elements, maybe you can measure them, and you can use that data. But Rudolph, your answer I think makes exactly sense to me.
Okay, Corneille, you can ask yours, and then if there's no other questions, then I'll go back to that question for the 4th archetype. Yes, Corneille.
Okay, cool. Thank you, Rolf. I find it very interesting the way that you explained the groupings of the archetypes. Is that the way that Moorcroft explained it in that reference? Because that's quite an interesting way to phrase it.
Yes, that's one reference I had, but I forgot to put the right one in. But that's the one from Wolstenholm. I don't know how to pronounce that. He's got 2 papers. One from 2003, 2004. There are 2 papers. I think I'll give them to Jon to share as well. Those papers.
That sounds very interesting because for this year's conference, I actually submitted something where I'm trying to translate mathematics into generic mathematical equations that mathematicians and engineers are very familiar with into kind of generic structures and furthermore into potential archetypes. And I find it interesting that because I didn't know about that work, and I think it could be useful for that purpose as well. Thank you.
Okay. Okay, let me go back and reshare the presentation. Get the right one. Okay, get the right button going here. Okay, is it this one?
Yeah. Yes, it says these groupings of relative control and I think out of control, and the other one was there's 3 groupings, I think.
Yeah, I think that when it just go down. Okay, yes, this is the last one, the 4th one. Yeah, this is the relative control, where you want to achieve a relative outcome for A. There's an action being taken to control the relative outcome, but that action it seems they've got a delay on there. It's not obviously visible. So if A is achieving his control, then you're reducing your action. However, the outcome, if the outcome increases, there's a compromising action somewhere else within the system that try and fight it, and that's reducing it. And then these 2 loops are actually fighting each other. So if you go to your relative control, is the threat is that you go either escalate or you're going to drift away between the 2 balancing loops. That is when you need to have a absolute value target that you're going to do, or an absolute outcome that you can control with the reinforcing loop, to make sure that you don't run away or drift away too much. You have something hard to stop it. The balancing loop, yeah, you need to instigate an absolute within it to rather than a relative control that you achieve at the back, at the bottom. And this is leading to the escalation. As one is increasing, the other one is increasing because of it, where the two are fighting each other, as well as you're drifting, the girls that are drifting. So you are trying to control two entities relative to each other. And the two feedback loops are nullifying the control that you want to achieve. Okay. I hope that helps, but I will give this to you. And I think it's also very well explained within that article from Wolstenholme. Just unshare and see here. Okay, Cornay, your hand is still up. Not anymore. Yeah. Cornay, your hand is still up.
Yeah, it's actually to do with the just the last things you said, Dr. Rudolph. Do you have maybe some simple examples of how those play out, like that we've seen maybe in a general sense? Those two, what you just explained.
Sorry, you broke up a bit. Say again, please.
Sorry, Dr. Rudolph, I mean, for the two that you just explained, maybe to give it a bit more real sense, do you have some simple examples at hand where those are seen?
Well, not really. Well, I think the escalation, okay, the escalation is typically a price war or an arms race. And where you two entities competing at each other to try and keep ahead of them. Price wars between airlines. The other one, for the other example, we have the drifting. One is escalation, and the other one is drifting goals. Yeah, that is typically where you change your goals to, for instance, symmetric pass rate. You're setting the bar lower to get more people to pass, but you're not achieving the control. Only the fewer people are continuing to pass because you're not solving the right problems. Does that help?
Yes, thank you. I appreciate that.
Gift. Okay, so gift is Richmond also have some generic structures. I don't think I've seen those. Do they differ from these gift? If you're still here to maybe switch on.
Hi, Doc. Yes. Can you hear me?
Yes, I hear you.
Yes, there's a few generic structures that were suggested by Richmond's work. And I think I found them to be much more user-friendly as opposed to the system archetypes that we've discussed today. I'll share that information with you.
Oh, please. I'd like to look at those.
Yeah.
Okay. Connor, you had a hand up again.
Sorry, Rolf, I just wanted to check if are those archetypes or those stock and flow generic structures?
Oh, okay. So they are not archetypes. They are generic stock and flow structures.
Oh, the generic structures for that you can, these archetypes are different from those generic structures where you have your oscillation or where you have the exponential growth or goal seeking. These are more, I would say, real life practical that you experience within organizations and typically within management, within complex situations. While those others are the building blocks that you can also use to build up your system that you can get into it. And your oscillation and whiplash and what's the other one? No. There are quite a number of those as well, but I see those are more building blocks. They are not really archetypes.
Oh, yes, that is correct. Apologies for that confusion.
Okay. Yeah. Yeah, they are quite, yeah, you can search anything. All these resources basically have those in that is about system dynamics. John, I can't put my fingers on them right now, but yes, both are useful, but they're separate things. I think the archetypes are more useful when you start interpreting your problem and to try and get a template to start from. And then you can use those other building blocks to start building up your simulation or the model that you want to replicate the behavior with. Victoria, I thought I saw your hand up earlier.
Excuse me, Mr. Rudolph.
Yes, I thought I saw you had a hand up earlier.
Yeah, my question is kind of basic. I would like to understand what is the main difference between cause and effect in the dynamic systems dynamics. But I if you rather to let this question to the end, I don't mind.
Okay. Cause and effect is the behavior that cause if you have many cause and effect interactions between the elements in a system, and that cause complex behavior of dynamic behavior. Now, sorry, what was the other part of the question?
No, that's it. Then the main difference between cause and effect. That's great. Thank you.
Yeah. And to try and model that, you can show the cause and effect behavior within your causal loop diagrams. And then once you understand how they influence each other, or what are the influences that cause the behavior of a system, you can translate those to your stock and flow diagrams, because you can have your cause and effects also captured in your stock and flow diagrams when you do your simulations within your software.
Okay, I see.
Okay. Any other questions? Yes, Faranak.
Yes. Hi. Hello. Thank you for your great presentation. I have a question. What is the best way to be proficient in modeling? Because I'm a beginner, and when I start to model a question or a problem, I think sometimes I'm in the vicious circle, and I don't know what to do. And most of the time, I read my resource from the first, but I don't think it's could be helpful for me.
Okay, I must be very honest, I'm not that experienced modeler myself. I'm still also learning. I think everybody here will state that they're also still learning, because this is a journey. I would say,
Yes.
first of all, simple as possible. Start as small as possible, simple as possible. If you do the model, it must make sure that you understand the model, you understand what you want to achieve with the model, and you can understand what the output of the model is. If you simulate that, if you can relate the behavior that you observe for the outputs back to the real life. I think if you can achieve that, with simple models. That is very important. Only,
You mean
yeah.
we should start with simple models at first?
Yes. Just yeah. If you can use a model with one stock to
Okay.
generate very interesting behavior already and oscillating behavior if you investigate it correctly. I think that's important because if you have a simple model, it's easier for you to understand what how the elements influence each other. Only when you understand the model and you know it's working and you know it's correct and it's good enough replicating what the problem situation is that you want to investigate, then you can maybe expand on it. But I think, Corneille, you are a better one to answer this question. If you want to come in here,
Thank you for answering. What? Thank you.
Okay, pleasure. Corneille, you want to add here?
Thank you, Dr. Key, for giving me the space, even though I completely agree with you, we're all still learning. And Faranak, you're asking a very interesting question and good question. For my side, I like what Dr. Rolf said about using simple stock and flows. If you look at what Jay Forrester did, the founder of the field, he actually like simulated the world almost by using majorly only 5 stocks, and that changed the world's idea about how economy works. Try to. So I would recommend definitely start small, keep it small, and always test it. As you're building, test what you're doing. It's much better to use something that you can explain to other people, that also makes sense to them. So don't try and build the whole stock and flow from the beginning. Secondly, what I do find useful is trying to map out what I'm expecting to see before I start modeling and then testing it against that. But for Anaki, it is a journey. So welcome on this journey and let us know if we can help in any way.
Thanks a lot.
Okay. Abdullahi, you have a question?
Thank you. Thank you, Sebastian. If when you have decided which system archetype to use, then do you have any trick of getting the variables to use in that system archetype? I noticed that you didn't break down your boundary into endogenous, exogenous, and excluded. Perhaps you take all that together in trying to explain the trick to get the variables once the system archetype is decided.
Well, I think if you want to have the system archetype that you think is present, but just as a side point, the same